Okay, we are looking at rearranging equations to y equals form from standard form. When we do that, we can decide whether the equation is linear or nonlinear. We can also see the rate of change in the y-intercept. I've got the steps listed out for you down here, and I am just going to do them and color code them as we do them so you understand what each step is. Step 1, add or subtract out your x. So we're going to do the opposite of what it currently is. And whatever we do to one side, we have to do to the other. So looking at this first equation, and it says add or subtract out my x. Well, my x here is actually 3 times x, so 3x. And I want to get rid of it so that I can get y by itself. I can do this by, I like to draw a line down the equal sign, so whatever I do to one side, I do to the other. I'm going to subtract out because it was a positive, and so to get it to 0, I need to subtract it out, and then I subtract it out over here. Cancels that out, that's gone, and now I'm left with y equals, I can't do 10 minus 3 because those are not the same term. One is multiplied to an x and one is not, so therefore I've got to keep them separate. They cannot be simplified. 10 minus 3x. So what I've done here is I subtracted out my 3x, and then step 2 says divide by the number multiplied to y. Well, y is just y, meaning it's an invisible 1. It's just one y. And so I don't need to divide it out because I want to just get y by itself, and it's already there. So in this case, we don't have to do step 2. Step 3 says you can now identify your rate of change and your y-intercept. So the rate of change here is -3, and the y-intercept is 10. And we would decide, is it linear or not? And the answer would be yes, it's linear because it has a constant rate of change of -3 for every 1. Has that constant rate of change. Change of y is -3, change of x is 1, so it is linear. Okay, looking at number 2. I've got 6x plus 2y equals 20. Step 1 says I need to add or subtract out my x. I'm going to draw a line down the equal sign. And so I'm going to subtract out 6x because it's currently a positive. Subtract out 6x, cancels that out. And I'm left with 2y equals 20 minus 6x. So I'm just going to color what I did. I just did step 1 and rewrote the equivalent form. Step 2 says divide by the number that is multiplied to y, and currently it's 2 times y. So I need to divide by 2. Whatever I do to one side, I have to do to the other, so I have to divide all of this by 2. Cancels that out. 2 divided by 2 is 1, so now it's just y equals, or 1y. And I have to do the same divide by 2 for everything here. This is 20 divided by 2 to give me 10. This is -6x divided by 2 to give me minus 3x. So step 2 was dividing by that y, or the value that was multiplied to y, and dividing that. And we've got our new equation. Now look what just happened. It's the same exact equation as the one that we have over here. Okay. The only thing different was this one was scaled up by 2. Everything is 2 times bigger. But when I simplified it down, it all came back down to this. Is it linear? Yes, it's linear because it has a constant rate of change of -3. Next one. Step 1, I'm going to add or subtract out my x. So this time it's a -2x, I'm sorry. So I'm going to add it out, add 2x. I'm going to add 2x. And I end up with 4y equals 20 plus 2x. There's my step 1. And then second step says that I need to divide by my number of y's. So I'm going to divide by 4. Cancels that out. Here's my second step. And so now I need to simplify that. I could just keep this as y equals and then have this as the answer, but it's not in simplified terms, so it's hard to see that rate of change in the y-intercept. 20 divided by 4 is 5, and 2 divided by 4 is 1/2, plus plus 1.5 x. I can now see my y-intercept, and I can see rate of change. So if I kept it in this form, I don't see that. It's harder for me to see. I can now see it's linear because a constant rate of change of 1/2, and it started at 5. And last one. I'm going to add or subtract out my x first, and because it's positive, I'm going to subtract it out. I'm left with negative y equals 10 minus 5x. So there was my step 1. Now here's a common thing that people might make a mistake with, and that is not including that subtraction sign down here, and you might just end up with y equals 10 minus 5x, and you would think you were done. But the problem is it's really negative y. So in order to get it just y and not negative y, we have to divide by, well, what's negative? It's negative 1. It's that invisible 1. Divide by negative 1. So that's step 2. Dividing by our number that's multiplied to y, and in this case it's multiplied by negative 1. And we end up with y equals 10 divided by negative 1 gives us the opposite of 10, which is negative 10. And negative 5x divided by negative 1 gives us the opposite of that, which gives us a positive 5x. So now I can see in this that I started my equation at negative 10, and I'm having a constant rate of change of 5, so therefore it is linear.